All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to continue our study of direct variation word problems by looking at this problem here, number 5. If you're coming to us directly from the previous video, you'll know that we spent nearly 30 minutes building this. We'll move much faster here on number 5. If you need the deep dive, if you need to know what's going on, please hit that previous video and put in the time. But once you get there, we'll move a little bit faster here. So at top speed, a rabbit can cover 7 miles in 12 minutes. If the rabbit could continue at this rate indefinitely, that means forever, how long would it take the rabbit to cross the 220-mile expanse of the Mojave Desert? All right. So there's a lot of extraneous nonsense here in this problem, but we're going to do the same thing we've been doing. The first thing we're going to do is write a rule, a direct proportion rule. This problem here is somewhat difficult because it doesn't say direct proportion or direct variation anywhere in the problem. All you're given between the two variables is this word in. Okay, so we can assume that that is directly proportional to. So that is distance is directly proportional to time. See, they got 7 miles is a distance measurement and 12 minutes is a time measurement. So the dependent variable here would be distance, and the independent variable here would be time. So remember, our rule is dependent over independent. So if that's true, then our rule is distance in miles over time in minutes. Okay. So now we fill this in with the information we actually have. We have 7 miles in 12 minutes. So here I'll write in 7 miles in 12 minutes. So from that, we can extract the constant of variation. Okay, this would just be 7/12 as a fraction. Okay, and this is the constant of variation. So this is the rule. Here's our rule. And here's our constant of variation, K. Well, now that we know the rule and we know the constant of variation, and this is an irreducibly simplified fraction, there's no common factors in the numerator and denominator. Okay, we can come over here and we can write our equation. So remember, the equation takes the form y equals kx. So if y equals kx, we can substitute in k, which is 7/12, and we can write an equation. Y equals 7/12x. Okay, so that's our equation. Remember that this is supposed to be in y equals mx plus b form. And just for your own edification and memory, that means plus 0, but it's just not written. You'll hardly ever encounter that in the wild, if ever. You have to know that y equals mx, right, indicates a y-intercept of 0, 0. So now we have our equation, and we can graph that equation. Now look at this carefully. Here's a distance that we're given. Right, we already know we're going to draw a first quadrant graph. The same kind of analysis here. First, we're going to draw a one quadrant graph, just like this one. But we got to think. I need to have my vertical axis be able to handle 7 miles, but also 220 miles. So there's a big range there, isn't there? So when I draw my vertical axis, I've got to be conscious of the fact that somewhere on that vertical axis I need to see 220. So we'll see how we're going to come up with that. Again, what I'm doing is I'm sharpening up my pencil here. It needs to be ultra sharp, or better yet, use a mechanical pencil if you have one. I don't, so. So now how we're going to fit 220 miles worth of dash marks on our vertical axis? Well, let's go ahead and draw a vertical axis. And we'll draw a horizontal axis. Okay. So this is the y-axis here. This is the x-axis here. And we know that this is distance in miles, and this is time in minutes. So how do we fit, this is 0. How do we fit 220 miles on this vertical axis? Okay. Well, let's go in and mark off the smallest increments we possibly can, which would be, for my protractor, that would be 1/8 inch increments. And again, be super precise. What I'm doing is I'm taking my protractor and I'm centering one of these lines over the horizontal axis. So I'm really being precise with my measurements. That's what takes so much time to kind of line it all up. All right. So here would be a hash mark. Here, here, here. Just going up 1/8 inch each time. You definitely need to use a ruler because your visual ability, even though it's fairly accurate, it's not good enough. You need to use a graduated. I mean, you could also actually use a piece of graphing paper, but somehow that feels like cheating. Okay, do the same thing on the horizontal axis. And I'm just going in 1/8 inch increments here. Okay, there it is. So, pause the video and make sure you've got this drawn pretty much exactly like it's drawn here. Now we can consider our increments. Now this is important. How am I going to label this? So up here I labeled 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260. Yeah, and that worked pretty well. That worked pretty well. I could label it again that same way. I'm trying to fit 220 here. I would be able to fit it, no worries. So yeah, I mean, that might work. Let's go ahead and do that. We know that that works. So this first marking here would be 20. Okay, then 40, then 60, then 80, and 100, 120, 140, 160, 180, 200, 220. Okay, and that's as high as I need to go. I don't have to continue labeling. Okay, so now we're going over to our x-axis, or I should label this axis. This is distance in miles. Okay. So you've got distance in miles. Down here, we're going to have time in seconds, but let's see what we need. Again, you got to look at what you need. So we need something that can accommodate a 12-minute, okay? But we also need to think, if it's 7 miles in 12 minutes, I'm going to need to have a big domain here of minutes to go up to 220 miles. It's going to have to accommodate more than 220 minutes. So I would also label this graph 20, 40, 60, 81, 20, 40, 60, 82, 20, 40, 60, 83, 20, 40, 60, 84. Okay. And I might think about doing that a little bit differently. I might be able to label it in increments of 25 minutes or even 15 minutes. Let's see if I did 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. No, I don't think that would be enough. So we'll just go with 20. I would say that thing we just did where we're trying to figure out how to label the graph, that's the hardest part. And notice I'm going to skip. I'm not going to try to cram 20, 40, 60. I mean, it's understood. So I'm just going to do every other label. So it would be 20, 60, 80, 100, 120. So I'm skipping a line and then writing the next thing. Oops, 160. Now I'm messing up my own graph. This is what happens when I'm talking while I'm trying to think. Okay. All right. So forget it and just label it all. 20, 40, 60, 80, 100. Okay, and then I can't fit, that's what I was saying, I can't fit 120, 140, 160, 180, 200, 220, 240, 260, 280, 300, 320, 340, 360. Okay, that should work. Oh, now I think I messed it up again. Oh no. I'm labeling this horizontal axis incorrectly here over and over again like a moron. Okay, let me try this one more time. It's driving me crazy. All right, so this is 20. I'm going to try writing it at an angle. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280, 300, 320, 340, 360, 380, 400. Okay. Now that I believe is correct. Oh, what a nightmare. Okay, so this is time in minutes. Okay, so now we're asked to figure out how long it would take. So this time we want time. We're asked to find out how long it would take for the rabbit to cross a 220-mile expanse. So we're actually going to go up here on that. We're given distance, and we want to find out what time. So we're going to graph our line in first. Okay, and that's 7 over 12. So how am I going to graph 7 over 12 on this little tiny graph with it being accurate? Well, what I'm going to do is I'm going to multiply 7 by 20, and I'm going to multiply 12 by 20 to get my values big enough to make sense. So we can see it. So 7 times 20, that would be 140. And 12 times 20, that would be 240. And so I'm actually enlarging the slope so I can actually plot something. So here's 140 on the y-axis. Okay, and now I'm going to plot in the 240 on the x. And I see that they cross there. Well, we know that that is just a magnification of 7/12. So that's a cross point. Here's a cross point here at 0, 0. So here's my slope. I've got it. I can draw in the line now. Again, be super precise. You're going to need to extend this line out. Pretty much as far as it'll go, right? Okay, and this is y equals 7/12 x. Now, we are given a 220-mile distance. We want to know what the time is. So what we can do is, let's see if I can use a different color here that would show up. Got one of these double-sided pencils. We're going to take our protractor and mark off at 220 miles a horizontal dotted line to see where it hits the line that we just plotted. So be super precise. Remember, your precision is going to pay off, and the predictive power of what you're drawing. Okay, so that hits right there. And now I need to swing this around and go down to the x-axis. Okay, so let's see what we got. According to this graph, at 220 miles, it is taking this guy something close to 380 minutes to do that. So again, with scales this wide, if we're close to 380, we've done a good job in drawing our graph. My difficulty in this problem was actually labeling the x-axis correctly. My attempt to save some time there was a disaster. But that's typical, right? You try to take a shortcut and you end up taking a longer route. Okay, but now let's evaluate it for real. So we've got our estimate. It's going to take 380 minutes to travel 220 miles. But let's see. Let's evaluate this. If y equals 7/12 x and y, because we're given y, and y equals 220, then 220, I'm just substituting 220 for y, equals 7/12 x. And now I just need to solve for x. So in this example, what I'll do is I'll multiply both sides by the reciprocal of this fraction here. So 7/12, I'll multiply both sides by 12/7. And I can cancel out everything on the right, leaving x by itself. Now what? Well, I need to do 12 times 220 over 7. And again, I'm gonna lean on the calculator here. Twelve times 220. Okay, and now I'll divide that by 7. 377.14. Remarkable. It's, you know, it really should make you feel good, because if you look closely at our graph, really closely at it, that red line is coming in just to the left of 380. Right? So just to the left. I mean, even with a hand-drawn graph, I mean, it should make you, I hope it makes you feel excited. So we get 377.14. Is the time, right? It's 377 minutes equals x. Very cool. Okay, so we've got several things here. Let's make sure we did everything we were asked to do. We got our rule. We got our constant of variation. We wrote our equation. We drew our graph. We did our work. And we solved the problem. So in this problem, we got everything we needed here. And we've done it in 24 minutes, so we shaved off, you know, about 6 minutes. But, you know, maybe these problems do take 30 minutes each to do it super precise. I'm sorry about the mistake here. You know, it is what it is. And we'll come back in the next video to work the final problem. So thanks again for watching. Please give this video a like. If you're using this video, just think about it. I put in the time. Maybe you could throw a like my way. Leave a comment to boost the video if you would. And share it with your friends. Subscribe to the channel if you haven't already. Okay, so you're always updated when I release new videos. Thank you.